all. Welcome to the Nullcon webinar series. My name is Karishma and I work as the Community Outreach Officer for Nullcon. We have been running Nullcon security conferences since 2010 now, where cybersecurity is discussed in detail among the industry, the government, and the tech community. The pandemic has been harsh on all of us, yes, but it has also given us as a community this opportunity to continue to share knowledge and connect with the global world by running online events like webinars, workshops, training, and resume clinics. In the coming time, there will be some really exciting webinars from Nullcon, which will be on topics like fintech, machine learning, malware analysis, etc. A very exciting news, we have also launched our Nullcon International Security Conference and Training in the online version, which is scheduled from the 1st of March to the 6th of March. Please do check out for more details because there's an amazing lineup of speakers and trainings for the Nullcon online version. Coming to today, we are having a special workshop session on extract data from damaged Android mobile device version 7.X.X by Teplinsky, Dimitri, and Pavel. I'll just do a quick introduction of our speakers. Teplinsky is a student at the Chelyabinsk State University. For more than 2 years, he has worked as a full-stack developer at FLab company. He focuses on developing complex web apps with secure back and front end. Dimitri is also a student at Chelyabinsk State University. He studies computer security. For more than a year, he has been working in the FLab company as a computer forensic specialist. He took part in more than 40 examinations and he specializes in mobile forensics. Pavel works as a security consultant at FLab and he focuses on embedded device security, testing, and research. He has an extensive background in the development of devices and working with hardware and is an expert on removing data dumps from memory chips. He is a professor assistant at Chelyabinsk State University and has participated in several conferences. So on behalf of all of us, I welcome them and thank them for this session. Before we go ahead, some quick house rules. As our today's workshop is for 2 hours of duration. I request all of you to keep your mic on mute during the session, but you can definitely ask all your questions and doubts in the Zoom chat box, and we'll get them answered for you. And we'd really love to have a really cordial session, so we hope that you cooperate with us and we have an amazing and knowledgeable 2 hours. Now, I would hand over to our speakers for today.
All right, thank you for the presentation, and I guess we'll start. So, as the presenter said, I am Maxim. We have here Dmitry and Pavel with us, and we are going to speak about extracting data from damaged Android phones. So we all work for FLab. FLab today is one of the leading companies in Chelyabinsk, which is a city located in Russia, and we are going to do some forensics today. We will have our speak divided in 3 blocks. So after each block, you can ask your question and we will answer them. So it will be a short delay between them. So I guess you can see the screen, guys, now. And this speech is for forensic experts, which also work with Android devices. Here at the screen, guys, you can see the software you need and the system requirements. All the links are going to be posted in the chat. So we're going to post link to software and to image we have. We're going to be extracting. You can start downloading right now, but there's going to be a password. Password is also going to be shared at the screen. So the password is, you can see it right now. It's also going to be in the chat. So please there's a warning. You can use the image only for educational purposes, so no sharing information, etc. Our company is not responsible for use the mobile device data you're gonna have. And so finally we can start the first part. We're going to unsolder the mobile phone we have, and we need only half of a minute just to move the camera here. So please take some time to do this.
Hi team. Hello guys, speaker are setting in the lab and they are very soon be back. So just wait for 5 minutes.
Прям там?
All right, guys. There was a small delay. Sorry for this. So I guess we can start now. So we have here a small Android phone we are going to work with. And first of all, we are going to disassemble it by pulling the back to pull off all the SIM cards, flash cards, and other components. Because the back isn't glue, we can just simply remove the cover. So now we're going to unscrew all the screws because it holds the other details we have here. If we have another situation when all the cover like is solid, we have to remove the glue which holds it together. But it's a simple case for now. All right, it's almost there. So all the screws have unscrewed, and now we are going to dismantle the case carefully. So there it goes. Okay, so the back part is now done. We're going to start the next part. Okay, so we have just removed the battery. Also, be careful with your all metal objects because if it fall into the circuit, it may cause problems. So next, let's remove a small sensor we have here, like cameras, buttons, some cables. There also can be screws, so we unscrew them. All right. So be careful with your eyes. Something can break. All right. Now we are trying to extract the RAM module. Okay, so we found the chip we're looking for. And now we're going to unsolder it. So first of all, let's use high temperatures for this. And we're starting to chip pop. So we're using tweezers. Be careful, there's high temperatures. Okay. So we have the chip right now. So we don't need the dryer anymore, we can turn it off. And now we are going to work with the chip, which we have just extracted. Okay, clearing the remaining things. Now wipe the chip out. Okay, so the bare metal path is about to end. And now we're going to use GTAG to extract the data. So we are connecting EasyGTech to one virtual machine. Just before this, we need to choose the right block, which fits to the size of the chip. Alright guys, so now you should see virtual machine we are using. So we launching the EasyGTech Plus, which is software we are going to use to extract the data. Let's wait till it launches. Okay, so we can see the menu now. We're going to press so all the settings are okay, and we're going to press check AMMC. Okay, this just was a small warning, so nothing serious. Okay. So we just relaunch the program just to turn on the English interface. Okay, so check the AMMC again. So we have found some partitions, that's okay. And now we are going to press the button read AMMC to save the data. Alright guys, so it takes some time to complete. We are going to move to the forensics part, but before we are going to do this, we will going to take a small break, like 5 minutes. While we do the break, you can write your questions and we'll answer them right after the break. So see you guys in a 3-4-5 minutes.
Guys, if you have any questions, please put them in the Zoom chat box and we will have them answered. Here in the Zoom chat box, you can put all your questions. Hi everyone, you can just keep the questions coming and we will shortly have them answered for you when our speakers are back within a short break.
All right, guys, we are back. So as we can see, there's a lot of questions, and we are going to answer them one by one. So let's read the first. Does Apple and Android have the same chip? No, they have different chips, different protocols, so there is definitely no. Uh, is it specific to Nougat and less, or will it work for higher versions? Uh, it depends on the version. It will work on versions below, or if you have device you've turned on encrypting. So it will work in this way. Let's proceed to the next questions. How do we extract iPhone damage? Is it the same method to follow? No, it's actually not, because it's definitely different device. So there's different chips, different methods, different protocols, probably different software. So it's all different. So you can't like strictly follow the things we did. So which chip is being examined? So the name of the chip is Hynix, which spelled like Hynix. There is, I think, no more information about the chip. So next question, does the method support different chipsets like MTK and Qualcomm? So we're going to...
Не зависит от процессора, все работа происходит в памяти.
So it doesn't depend on the processor. All the work happens with the memory, so it depends on the image, not on the chip. So probably yeah. Can we use the same method for Android version higher than 7?
Там же было. Все зависит от производителя.
It all depends on the manufacturer. There are some questions about participation certificate. It's not clear what is participation certificate, so please provide more information about the certificate. We actually can't understand the meaning. Can you please tell us about the device for which chip is connected to? Типа, к какому чипу мы подконнектились? Нет, одевайте.
Huawei.
Это был Huawei.
То есть
Huawei Honor.
The device was Huawei Honor, so simple Android phone. Is Android OS also show I'm a cat on chip analyzers? I guess it depends on root rights. If you have root rights, then yes. Otherwise, no. Then can we embed this chip into another same phone to show the data in another phone? Павел?
Еще расскажи.
Мы можем строить этот же чип, чтобы он показывал те же данные в другом телефоне.
Ну, чисто в теории можно, но все зависит от телефона.
Yeah, theoretically we can, but it depends on the phone you are using to this. But theoretically, yes. So next, is it necessary to use dust-proof room or area for chip of forensics activity? No, it's actually not necessary, but you have to keep your working place clean. So next, there was 2 chips, are both used for same purpose or other has some other? Говорит, типа было 2 чипа, все ли они используются для одинакового? Ну, допустим, оба ли они память, или там один чип за одно отвечает, другой за другое?
Один это был процессор, а один память.
So about 2 chips, one chip was the processor and the other one we extracted was the chip which contains the data, the image.
Еще первый чип может быть RAM память.
And or otherwise, the other chip could be the RAM module. Okay, so let's proceed. Without using GTAG and chip-off technique, can we extract data of mobile devices? Можно ли мы без использования GTAG и высовывания чипов достать данные с телефона?
Не поврежденного. Непонятно с какого. С работающего, да.
So that's okay. That's not a clear question because we can extract data from not damaged phone. Like if it's working, then yes. Otherwise, depends on the phone you have. If it's like 100 destroyed, there might be problems. Or if you have any kind of vulnerabilities on your device. So let's proceed. Okay, yes, the workshop is recording, I guess, so you can find the recorded workshop later then. After chip forensics, can we use the same chip again? Theoretically, yes, but most times the chip got destroyed because it's a dangerous method to use. So not in all the cases. So how to identify the specific chip to be examined on the motherboard? Как понять, что это именно тот чип на материнской плате, который нам нужен?
Ищите маркировку и просто ищите информацию в Google.
So you just need to try to find out some marks on the chip. Probably the RAM chip contains something like RAM. The memory can contain something different, so it's probably something you need to use. And the last one, will the recording be shared as I have joined it late? Yeah, as I said, yes, it's going to be shared. So I guess, guys, there's no more questions here. And we have another one. Any other software technique tools are available? Technique using Oxygen Forensic Toolkit. So about forensic question, we'll answer the forensic questions later after we are going to show you our forensic part, and then we're going to answer them. Also, high temperature will drastically reduce the stability of the chip for further use. Yes, that's right. You're right. And we are going to proceed to the next part. So Dmitry is going to share the screen. Can you guys please tell us, do you see the screen we are sharing? Please write in the chat.
Yes, we can see your screen.
Okay, thanks. So we're going to extract some data from the chip we have just got chipped off. And most Android application data stored in SQLite-free databases. So we're going to examine them. First of all, let's see the image we have. Guys, have you already done, if you want to proceed forensic parts with us, we have provided in the beginning the image. Has anyone downloaded the image? Was there any problems? So, not yet. Anyway, you can just watch the process we are doing, and then we will have the interactive part, and you will try something by yourself. All right. So now all the eyes on the screen. All right. So here we have about the link. So, yeah, we'll share the link again later, like in 1 minute. So about extracting data. We have file which is called build.prop, and it contains all the settings you need in the phone. Like user data contains settings application, and user data, all remaining memory space is allocated to the folder. System, which is contains Android data, then boot, which is contains the kernel and RAM disk, recovery, which is recovery console, and set of console applications, and cache. So we are going to proceed to the system section. All right. So system section contains the build prop file, which I was talking about like a minute ago. So there's raw build and raw product strings, which contains all the settings we are interested in. Then let's move to the user data image, which contains a lot of interesting information. We'll start examining the contacts folders. So we have here many folders. Let's find the contacts one. Okay. As we can see, there's lots of .db file. This is just a simple SQLite database. So we'll just open it into the DB observer. And we have here some databases like contacts, but as we can see, the contacts database is clear. It does not contain any data. So we'll just pass it, but let's move to other interesting databases, because it's okay if there's no data in some database. And we have here calls. So calls is also interesting. We have here all the calls we have. We have number, date. Date is stored like a Unix timestamp, and some information. Okay, let's proceed to the next interesting database we have. All right. Next, we have here the MMS SMS.db. This database contains messages, and as we can see here, there are some also there are some tables we have. Here we can see the body, which is the text of the message. Also, we can see date it's sent. Also, we can find in the database all the contacts it was sent for. So that's actually so many information, but we have something more. Let's proceed to the next database we have to use. And the next database is history. As we can see, it does not have the .db extension, but nonetheless, we're going to open it in the DB browser because it's actually a DB. You can try to open it in other things like Notepad, C++, Notepad, and then see this is just a simple database, nothing else. Yeah, so as you can see, it's SQLite format free header. All right. So here you can see the title of the message and some other interesting information like URL, last visit time, which is actually also timestamp, and other. And now let's see to the login data database. And here we have, as we can see, we have username element, username value, and password element. So it means we have just accessed usernames and password. But we also have password value, which is blob, a binary large object. So it means it's kind of obfuscated. As we can see, there is no plain text passwords. It's obfuscated or encrypted, and if you want to extract clear passwords from it, you should do something more. Let's proceed to the next database we have. All right, let's proceed to the messengers. We have here a database called kim.sqlite, which is a database from Russian social media called ВКонтакте. And as we can see, there's a lot of tables which contains a lot of information. For example, we have here messages. And here we can see the text of the messages. If you can see, it's just plain text, so we can read all the messages, all the messages were sent from the device. So, and some other different information, system information. Yep, so let's continue to the next databases we have, and it's camera. So it's pretty simple, that's just the photos that were on device. It's not probably interesting to watch the photos, so we're going to use EXIF tool to extract the metadata which contains on the files. As we can see, there's a lot of metadata, like it probably contains geo information, time, encoding, camera, etc., etc. So it can be a lot for a forensic expert because it can contain some data. Right. But if you can see, you also can see the photos because they are plain photo. All right, the next database is going to be mail app. So it's about emails. Mailbox.db is our file. So here we can see some data in tables, and let's proceed to next tables we have. Oh, here we have some interesting information like different emails that were used to send the email, and we also have titles, we also have some text. So it's plain text messages, plain text emails. You can read them. And here we have the full list of the messages, of the emails, like formatted HTML body, and some text, which is also plain text without any HTML markup. So there's also other information in this database, but we'll proceed to the next database we have. And it's going to be Wi-Fi. So we can see Wi-Fi data we had on the device is almost plain text. So we can see the SSID of the point we have. It says interface open for now. And we can also find creation time, update time, and other. But there are no passwords for the Wi-Fi points. And some interesting information in accounts.db. And as we can see here we have emails, here we have password, which we have, some passwords are encrypted, as we can see the first password, but the third one is actually plain text. So it depends on the application you use. If they encrypt the data, so that's probably needs something to work with. And guys, that was all the databases we wanted to show you. So we hope someone downloaded the image and the tools. We guys hide some data in the image, so you're advised to find it in the image. It's like a mini simple capture the flag. So guys, you will have up to 10 flags, which have format flag, uppercase, number, semicolon, and then some flag. So you can just find the data in any database we have just shown. And now we'll guys give you some times, take a small pause, and then answer the question about forensics parts. Okay, so see you guys in 3, 4, 5 minutes.
Hi everyone, we are again on a short break for about 3 to 4 minutes. So if you have any more questions, please put them in the chat box, and once the speakers are back, they'll answer them for you. So you guys can keep the questions coming, and let's have a fiery discussion in the chat as well.
Понятно.
All right, guys, let's answer the question you asked about forensic parts. So the first one was, is it possible to get the data about Android Pay credentials? And actually the same question, is it possible to decrypt social media chats and payment details? As you could see uh, from the forensics part, there were some data about social media ВКонтакте, but about Android Pay, it's hard to say because it depends on the application you're going to retrieve data from. If it's Android Pay, it's probably highly secured, so it couldn't be that easy to extract like plain text data. So theoretically, yeah, but practically uh, you should try, but actually it's not that easy. Okay, so can we recover complete data from that phone when USB debugger is disabled and without root access? And Dmitry?
Нет, потому что надо подтвердить, что телефон использует RSA-ключ с компьютера.
So the answer is no, because the device need to be confirmed that it uses the RSA key, which is connected with the computer. All right, so there is no more question about forensics part, I guess. And you guys, if you guys have any question about the tasks we gave you, you can ask them in the chat and we'll answer them. But it should be easy because the flags are plain text. Almost all flags are plain text, so there is nothing hard to do. And here we have question, how to generate wrappers for all the extracted data, and what about authenticity of data? Yeah, sure, we can generate like wrappers. We can convert SQLite database into CSV, and now we're going to show you how to do it. So as you can see, there's export table as CSV file, and there's just going to be a plain text CSV, which you can share because plain CSV can be opened by many programs like OpenOffice, etc. So that simple wrappers can be generated. We have a question here. There is a chance for editing in DB browser for SQLite. How to avoid that? Well, there is a variant for this problem. You can just mount the image you have as read-only, like mount in Unix-like systems. So that's the way you can protect your database from editing. And we have also question. Sorry, I joined late. So if I understand correctly, this was extracted from the dead phone or directly from chip, or the phone has USB port enabled with passport protection. Я так понимаю, мертвый телефон, да? Нет, типа из мертвого телефона или по USB что-то. Больше из мертвого телефона, да?
Ну, чипов можно рассказать, чипов. Я просто видел вопрос.
Окей.
Есть вопрос.
Да, я отвечу. So, yeah. There were no USB connections. We just chipped off the chip, the memory chip, and with GTAG we used GTAG to extract data from it. So no USB ports were used to extract the data.
No.
The phone was Huawei Honor, and the full model will be written in the chat. Well, the workshop will be held like for 1 day. It ends tomorrow for our part, but the other parts probably will be last longer. But it's not related to us, like our part about extraction data. Do you guys have any question about the tasks, or maybe you need some help? You can feel free ask your question in the chat. Okay, guys, we have some questions, and cost of EasyJTech device or alternate option for this one. So the cost is $230, and yes, there are annealers. You can use any eMMC reader if you want. PCB phone is generally surface mounted, so was JTech identification simpler? So about this question, it's not clear. What do you mean easier? Uh, I mean, there's nothing to be easier as much, but if you want to ask about some details, just please clarify the question. So, meanwhile, can you demonstrate or share links to find the memory chip details and how to extract them from PCB with some do and don'ts? Wait a minute. Okay, we'll provide the links in the chat. We have a message here. Please discuss the question shown as tasks. So there are simple tasks. Previously, we show databases which contains interesting information in the from the device. So we hid some flags in the image, so you can find the flags. If you have any question about the task, please ask them. If you have found some, just tell us about your progress. Hi, will the recordings be available after? The organizer said yes, it will, so I guess yes. And guys, there's also some information. We're going to show one of the flags just to clarify what you have to do after 15 minutes if someone have any kind of troubles. We have a question here. Image from the chip is formed in which format, DD or E01, etc. And can the analysis be carried out using any open source forensic tool like AutoPsy? So the image format is just a byte copy. So there is just a plain byte. And about AutoPsy, yes, you can use AutoPsy on it, but you should understand that the automated tools can extract not all the data you can find by using your hands. So yes, you can, but it's better to use like humans to do their careful work. So guys, in 3 minutes we're going to show how to get the first flag. And if you guys have any question or you found any flag you have, just share the experience with us in the chat, please. So guys, the time has come to share the first flag. Now you'll see how you can get it from the image we provided.
Ты точно шеришь? Да.
So we'll open user data image. Then proceed to data folder. Then we need the database MMS SMS that we have shown earlier. And let's find the needed table. So the table is called SMS, and as you can see, we can see at the column body flag column flcon1. So that's the flag. You can find it by yourself in the image. So there are also different other flags hidden by the same principle. So yeah, just try it yourself. And there's also we have question where to open that tasks.bin file. You can download it from the link we shared in the beginning, and you can open with 7-zip. So it's just an archive. You have to extract the image and then work with it like with a regular Android image. Okay, guys, so we are going to share all the flags in 6 to 7 minutes. So, yeah. So in tasks that begin on which file or folder we have to focus particularly. So there's the tasks, we have a list, and we also showed the databases you should look in the previous part, like in the forensic part. So those are, as you may see for the first flag, it was SMS MMS or MMS SMS.db. So the other are kind of similar, like context database, etc., etc. Okay, guys, so we're going to show where you could find all the flags. So let's proceed to the second flag. And it was in the database context2.db. And as you can see, we have here table contacts, and the column has phone number, which contains the flag2 FL1 exclamation mark. So let's proceed to the next flag. And the third one was in history database. So we have here table called URLs, and as we can see in the title, we can see the third flag. So the fourth flag was like really near. We're gonna use different database in the same folder called login data, and the flag is actually in the first table, table called logins, and password value is the column you need. There's also flag with the hash. You can guess what this hash is and try to crack it if you want. We'll show you guys how you can do it. So just paste the hash. Okay, that was the wrong decryptor. Let's try this one. And as you can see, it hashed as the word admin. So that was 2 flags. The 6th flag is a social media of Contacti folder. We have here folder databases. The same database we show. And we need table messages. The body column contains flag. The 7th flag was an photo metadata. So you have to use EXIF tool just to extract the metadata information. And as you can see, the make field contains the flag. Okay, guys, next flag is in mail app folder. So we are going to use mailbox.db. And in the table mail message content, we see in the column led by displaying another flag. For the next flag, we'll examine network history.txt file. And as you can see, in the end, we hit the flag. And the last flag contained in users slash no slash null slash accounts.db. And in the first table called accounts, you need the password column, so there is a last flag. So guys, those were all flags you could find. Please tell us if you have any other question, or if you found any flags, if you found all flags. We are interested to share your opinion about the interactive part and the others part we were talking about. So please, if you have any questions or any information, type it in the chat.
Hi guys, if you have any questions about the tasks or the workshop or about the talk, please do type it in the chat and we can have them answered for you while we're here. Guys, do you have any questions? Please type it in the chat box.
Can you please provide more information? What certificate do you mean? Like, we
Uh,
actually don't get.
I think what they're meaning is the certificate of attendance, certificate for attending this workshop. And no, there will not be any certificate for attending this workshop.
Yeah.
Okay, we'll wait for one more minute. If you guys still have any questions, please do type in the chat box. Okay. Thank you to our amazing speakers. And I think we have a question. Oh, yes, the session is being recorded and we are going to upload it on our YouTube channel, the Nullcon YouTube channel. So you can find the recording there.
Yeah. So guys, we would like to say thanks for the participations. So I guess our time has come. Thank you. It was Maxim, Dmitry, and Pavel, a Flap company, Chelyabinsk, Russia.
Yes, thank you so much, guys. It was an amazing session. I am sure, looking at the feedback, our participants really had a lot of fun, and it was a knowledgeable session for all of them. And thank you all the participants for joining us for the Nullcon webinar. And we have our webinar series wherein we have webinars every week. So you can join our next session on machine learning for intrusion attempt detections by Varun Kohli, which is on the 22nd of Jan at 4 p.m. Indian time. So if you guys want to keep having more knowledgeable sessions like these, please tune into our webinars. Thank you again to our speakers and to everyone who helped us translate. We are really, really thankful for your support. Have a great evening, guys. Thank you so much.
Thanks. Bye.
Bye bye.